Okay, so we are going to start the chapter on data analysis, and you're going to watch a lesson on simple probability. And then when you're finished, we have assignment 31, simple probability worksheet. Okay, so you should all have the new notes packet. This will be our last chapter before the final exam. Okay, let's talk about probability of an event. So probability of an event is the number of favorable outcomes to the total number of possible outcomes. Sample space. So this is the list of all possible outcomes. So for example, what is the sample space when you roll a die? Well, think about it, right? So how many sides do you have? You have 6 sides. So you can roll a 1, a 2, a 3, a 4, a 5, or a 6. That is your sample space for when you roll a die. So if there are n outcomes, okay, so for example, in the last one, there were 6 possible outcomes, the probability of each equally likely outcome is 1 over n. Okay, so just for an example, what is the probability of rolling a 4 on a die? Well, you only have 1 4, so you have a 1 out of 6 chance of rolling a 4. Now, the probability of an outcome is always between what and what. Well, let's think about it. If I say, what's the probability of rolling a 7? Well, there is no 7 on a die. So there is a 0 probability of rolling a 7. But what if I said, what's the probability of rolling a 1, a 2, a 3, a 4, a 5, or a 6? Well, that's 100% chance, and we would say that is a probability of 1. Now, most of when we write these, we are going to write the probability as a ratio. So like I had above, 1 over 6. Okay, so when we write these, we're going to leave it as a fraction. We just want to make sure it's reduced. Okay, so probability of rolling a 2 or a 3 on a die. Well, that's 2 out of 6, which we're going to reduce to make that 1/3. Okay, what about the probability of rolling an odd number? Okay, well, how many odd numbers do we have? We have 1, 3, and 5, so 3 of them out of 6. So you have a 1 out of 2 chance of rolling an odd number. Probability of rolling a 5, that's 1 out of 6, right? They only have 1 5. Well, what's the probability of not rolling a 5? So that would be a 1, 2, 3, 4, or a 6. So that would be 5 out of 6. Now those last 2 examples, rolling a 5 and not rolling a 5, these are examples of complements of each other. Okay, so the probability of rolling a 5 was 1 out of 6. And the probability of not rolling a 5 was 5 out of 6. So what are we always going to get? We're always going to get 1 for that. So the sum of the probabilities for any 2 complementary events is always 1. Okay, a bag contains 3 red marbles. Okay, so we have 3 red. We have 6 blue. And we have 5 yellow marbles. 1 marble is chosen at random. Find each probability. Now this time, if you have your calculators handy, I want you to write each as a ratio, a decimal, rounded to the 100th, and we're going to change it also to a percent. Okay, so let's see. Probability of a blue. Well, first of all, how many total outcomes do we have? We have 3 plus 6 plus 5, so that total is going to be 14. So the probability that I grab a blue marble is going to be 6 out of 14. So reduced, that's going to be 3 over 7. On our calculators, go ahead and do 3 divided by 7. Round that to the 100th place. That's going to be 0.43, which is 43%. So you're going to actually have the answer written 3 different ways. Okay, probability of a red or a yellow. Okay, we have 3 red and 5 yellow, so that's going to be 8 out of 14, or 4/7. Okay, this is about 0.57, or 57%. If I'm going too quickly, feel free to pause. Maybe you want to pause here and try the next 2 on your own and see if you got them right. Okay, so the probability of not red. Okay, not red. So that means it would have to be blue or yellow. So there are 11 of those. So 11 out of 14. That's also already reduced. And then as a decimal, plug that in, we get 0.79, or 79%. Okay, probability of neither, so not blue or red. That means it would have to be yellow, which would have to be 5 out of 14. That's already in reduced form. We get 0.36 for a decimal, which would be 36%. Okay, so the next thing we want to do is take a look at what's called a tree diagram. Okay, this is a method used for counting the number of possible outcomes. The last column shows all the possible outcomes. Okay, so we want to draw a tree diagram for the different options for ice cream. You can choose between a sugar cone or a waffle cone. You can choose a scoop of vanilla or chocolate ice cream, and you can choose sprinkles or nuts for topping. Okay, so let's start with the first. We can have a sugar cone or a waffle cone. So I'll use S for sugar. Let's leave us some space, and we'll do W for waffle. Okay, then we can have vanilla or chocolate. So branching out here from the S, we can have vanilla or chocolate. Or we can have the waffle cone with vanilla or chocolate. And lastly, we can have sprinkles or nuts. So we're kind of following this first line. So after this, so you can have a sugar with vanilla, and then you can have sprinkles. I'll just do SP, or nuts. You can have a sugar, chocolate, then sprinkles or nuts. You can have a waffle cone with vanilla, with sprinkles or nuts. You can have a waffle cone with chocolate, with sprinkles or nuts. So you can see here, you can follow any one of these. It'll give you the different variations. So you can have a sugar, vanilla, sprinkles, or you can have a waffle, chocolate, and sprinkles, and so on. And so if you look at the column all the way here, you have 1, 2, 3, 4, 5, 6, 7, 8 different options. Okay, fundamental counting principle. So if there is an event that can occur M ways, followed by another event that can occur in N ways, then we multiply those two numbers together, get the total possible outcomes. So actually on that previous page, we can look at this. So for example, you had a cone, so you had 2 different cones. You could have vanilla or chocolate, that's 2 options. And you can have sprinkles or nuts, that's 2 options. And so if we multiply that all together, 2 times 2 is 4, times 2, 8. Notice that's how many different options we had at the end. Okay, let's take a look. Kathy needs to make a 4-digit password for his login on a website. The password can include any digit from 0 to 9, but the digits may not repeat. How many possible passwords are there? Okay, so there's 4 digits. So that means we're going to multiply 4 different number of options. Well, how many digits do you have 0 through 9? Well, that's 10 digits, right? Counting 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 10. But since they may not repeat, now for the second digit, I've already used one of those numbers, so I can't reuse it. So that means I only have 9 digits left to choose from. Now that I've chosen 2 of them, I can't repeat those first 2. So that means I have 8 digits left to choose from. And followed by the 4th digit, I only have 7 digits to choose from. So we're going to multiply that all together. So we get 5,040 possible passwords. Okay, so let's use that fundamental counting principle to find the number of possible outcomes for each situation. Okay, well, let's see here. Here we have an answer sheet. Let's see. So we have the first 6 problems have options A through D. So that's 4 times 4 times 4 times 4 times 4 times 4, right? And then the next 4, you only have 2 options. So times 2 times 2 times 2 times 2. So this is really 4 to the 6. Or sorry, 4 to the 6, and then we have 2 to the 4th. When we multiply that all together, we get 65,536. That is all the possible ways that we could fill out the answer sheet. So the chances of you just randomly guessing and getting that all correct would be 1 out of 65,536. So chances aren't likely that just randomly selecting them is going to get you the correct answer on the quiz. Okay, a die is rolled 4 times. So a die, we already said, has 6 options. So that's the first roll. Can you roll the same number a second time? Sure. So that's going to be 6 times 6 times 6, which is 6 to the 4th. So you can use that when you're typing it into your calculator. You can do 6, and then you have this caret symbol, and then 4, and then press enter. That'll save you a little time. 1,296. Okay, number of class rings that can be created. Okay, so we have 10 choices for the number of metals, 2 different finishes, 12 stone colors, 5 different stone cuts. Side 1 activities, we have 20. Side 2 activities, we have 20. And we have 2 different band styles. So that's 960,000 different ways to create a class ring. Okay, so that is it for the lesson. Go ahead and continue on the Google slide, and then you can work on the homework when you are finished.